Let's look at another example. Now that we have a way to selectively execute certain statements in a program using decisions, it is time to go back and fix up the quadratic equation solver. And let's remember what the program was. The program would ask for three values, A, B, and C coefficients, and then calculate a disk root with using the math.square root function, and then it would calculate root 1 and root 2. This program crashes when it is given coefficients of a quadratic equation that has no real roots. When b squared minus 4ac is less than 0, the program attempts to take a square root of a negative number. Since negative numbers do not have real roots, the math library reports an error. We can use a decision to check for this situation and make sure that the program does not crash. And let's try this in the editor. So first, let's open the quadratic program from the lecture 3 folder, and then we're going to save this as, and then change the location to lecture 4, and let's name it number 2, quadratic number 2. So before we do anything, let's remember what this program does. So this program finds the real solutions to a quadratic equation and then input A, B, and C, and then calculate the disk root with passing this equation to the math.square root function, and then after this calculate root 1 and root 2 and then print the values. So let's go ahead and try this first. This program finds the real solutions to a quadratic equation, let's say 2, 1, and 0, and it looks like the solutions are 0, 0.0 and 0, 0.5. So however, let's try this again. Let's say 2, 1, and 1. And notice that the program crashed. It gave an error in line 17, which is this line. And then it said that math domain error because we cannot calculate the square root of a negative value. So what we can do is we have to find a way to check whether this equation or this expression result in a value that is less than 0 or not. And let's fix this program with an if statement. So first thing we want to do is we want to take this out from here and calculate it outside the math square root function. So we're going to create a variable called discrim, in short for discriminant, and then it will calculate b squared minus 4ac. Then we're ready to create an if statement and then say if discrim is greater than or equal to 0, then calculate the disk root with discrim, and then calculate root 1 and root 2 and print the value. Okay, I want to make sure that I put a backslash n here. Alright, so and another backslash n here, probably, sure, why not? Or maybe not necessary. Okay, so let's try this. So we're going to say 1, 3, 2. Looks good, right? -1 and -2. What if I say 1, 2, 3? Oops, 1 first, 2, then 3. Nothing happened because we basically hear that b squared, which is 4 squared, 2 squared is 4, 4 minus 4 times 1 times 3 will result in -12. So 4 minus -12 is -8. -8 is not greater than or equal to 0, so we didn't proceed with this part of the program. However, one thing you notice here that if your program doesn't have real roots, like this example 1, 2, and 3, 1, 2, and 3, nothing happens. So we neither get a feedback nor get any kind of roots. So what if we actually rewrite our program? So one way or the other, we give the user a feedback. So for this, we can say, let's rewrite this. This time I want to check whether if it's less than 0, and then I want to give a feedback saying that print something like this equation has no real roots, \n, this equation has no real roots. Alright, if that's the case, this scrim is less than 0, we'll print this, else we continue with the rest of the program. So this will make sure that one way or the other we get feedback. So if I say 1, 2, and 3, this equation has no real roots. However, if I rewrite, let's say 3, 1, and 2, this equation has no real roots. Let's retry some values. I'm meant to say 2, 3, 1. So we get 0.5, negative 0.5, and negative 1.0. So one more way to look at this equation is that if the discrim is 0, so if this evaluates to 0, we actually get a double root, not two distinct roots. So let's see an example. So if A is 1, B is 2, and then C is 1, we end up having 0 discriminant, and that's why the root is negative 1, negative 1. So in that case, we don't have to calculate and print this twice. We can find a way to say, let's say L if discrim is equal to 0, we calculate the root because it's a single root, and then we can say negative B divided by 2 times A. Alright, so since this is 0, so we only have negative B divided by 2 times A, and then we can print the value. We can say print and then say \n. This, we can say there is a double root at, and then print the root. Okay, so we have an if, elif, and else. And then if you try this with 1, 2, and 1, there is a double root. If I try 1, 3, 2, we get two distinct roots. Or if I try 1, 2, and 3, this equation has no real roots.